Okay, if you look at this question, they say which of the following shows the best choice of reagents and conditions to carry out transformation. Okay, so if you look at this side chain here, this ketone, right, it's actually a 3-directing. Okay, it's actually 3-directing. You can find this out from your data booklet. Okay, the thing about this type of question is this. You can see there are 3 substituents here, 1, 2, 3. So what we're going to look out for is the first 2 substituents, you will have to direct the last substituent to the same place, all right? Which means, say for example, this group and this group, right? So if you notice this alcohol group, okay, let's give you an idea. This group here, if you check your data booklet, this is like an alkyl group, okay, because this is still a CH2 CH over here. Treat this like an alkyl group. It's actually 2,4 directing, and Br here is actually 2,4 directing also, right? So if you want to put in the NO2, right, you want to put in the NO2, this is the perfect time, because this group here is 2,4 directing. It will direct any electrophile to this position, and Br, which is 2,4 directing, so there's like 1, 2, 3, 4, it will direct the electrophile also to this position, right? So which means that in the very last step, you direct the NO2 to this position. Okay, so let's see how it's done. So the answer is actually B, right? Let's see why B is the best answer. So if you do the first step, we add bromine and FeBr3, right? This group is actually 3 directing. So if you count 1, 2, 3, right? So the electrophile that's generated from here, which is the Br plus, will be directed to the 3rd position. So this is what you get at first, right? So but the only thing is this is actually 3 directing, and this is again like 2,4 directing, right? So based on that, the Br will direct any electrophile to this position, but the ketone will direct any electrophile to this position because it's 3 directing, right? So they don't direct to the same place. So what you need to do is to actually do hydrogenation. So hydrogenation, or we say is reduction. So what this does is actually converts the ketone to a secondary alcohol. So this is what you're going to get next, right? So you're going to get this at the end. So the ketone became a secondary alcohol, and a secondary alcohol over here, because this is still a CH, so we take this group here, it's like an alkyl group, it's actually 2,4 directing. So at first it was 3 directing here, but now it becomes 2,4. And of course, Br we know is also 2,4 directing. So these two will now direct any electrophile to these 2 positions. So I'm going to just count. So the secondary alcohol is 2,4 directing. It will direct any electrophile to this position, right? So there's like 1, 2. You can see that. So if it based on the Br, okay, based on Br, it will direct any electrophile to the 4th position. 1, 2, 3, 4. Right, so they do direct them to the exact same spot. Okay, so which means that's the last step. Concentrated HNO3, concentrated H2SO4. So this is nitration. So they generate what they call the NO2 plus electrophile. It will be directed to that place that is directed to the same place by the secondary alcohol and the Br. So this will be your final answer, right? So let me draw it out. Okay, which is actually the product over there. Okay, so the Br over here and the NO2 will be over here. All right, so that's why B is the best answer.